All right, so we're going to do just a quick start on parent functions today. All of these, with the exception of one, should be a review to you because you do this in Algebra 2. All right, but that's why we're just going to not spend a whole lot of time actually going through it, because this is stuff you should have already. And we're going to do more stuff with this. So a function family, group of functions with similar characteristics. The parent function is the simplest of the functions in a family. You must be able to recognize each of these functions along with their characteristics. You should be able to recognize them by the graph, by the name, and by the equation itself. Some of you don't recognize them, and that's why you're having trouble with some of these when we're doing domain and range, and you're not sure if their asymptotes are there or not, because you don't even know what you're looking at. Okay, so this one we're going to do these together. So we're going to start with the most basic one, and it is a linear, so you don't have any questions about what they're called, because the names are all right there, spelled correctly and readable for you. And then the function itself. So what would the equation look like? Okay, if it's the simplest, okay, but this is a function, so we should write it as f of x. Okay, so f of x equals, is y equals x plus b a line? Yes, but once you throw in there then m and a b, where m is not 1 and b is not 0, then it's not the parent function anymore. And these are functions, so we want to make sure we stick with that f of x. Y equals x would also give you the same graph and everything. But then on each one of these, you're going to go through domain, range, intercepts, all this stuff, plus a little bit more that we'll add later. When domain and range, if you're not told what form to put it in, then I'm expecting interval notation, because I told you that's when we're going to use the most. So the interval notation, the domain of a linear parent function, what would the domain be? Negative infinity to infinity. And we never include our infinities, right? What about the range? Negative infinity to infinity. Okay. Now, when it says intercepts, what form should it be written in? Ordered pair. So the x intercepts is what? 0, 0. Is that the only one? Yes. Okay. Y intercept, what is that? 0, 0. They happen to be the same number. Okay. All right, so extrema. I was wishing I had fixed this before I copied it, but now it's too late. Really the intention there is not just extrema, but the critical points. So our extrema is like our max and our mins, relative and absolute. But then we also have that point of inflection in there, which is an important point for us. It tells us about shape and how we're going to graph some of these. So even though it's not an extrema, that would be included in this list if we had one. All right. So extrema. Do we have any max or mins here? No. Okay, and do we have any point of inflection? No, so it's none. All right, so if you still have that second quiz because you were absent, then are they stacked up? I'll come get them in a minute then, it's fine. All right, increasing intervals. So is this function anywhere? Yes. From negative infinity to infinity, good, it's increasing the whole time. To infinity. So is it decreasing? No, it's not decreasing at all. So if we're increasing through the whole domain, there can't be any here. Now, we know we never include our infinities. What if these were numbers? Like if my interval was actually like from 3 to 4 or whatever. Would it be possible to have brackets here instead of parentheses? No. For increasing and decreasing, there's always parentheses. We never include that max or min with it. Okay, and that was one thing that was a little confusing to some of you. That at that point, it's not increasing or decreasing because it's switching over. Right. So then our end behavior requires a little sentence. So as x approaches infinity, f of x approaches something. So as x approaches infinity, then what is my infinity also? Good. And then as x approaches negative infinity, f of x approaches what? Negative infinity, I'll agree with that? Yes, negative infinity. Okay. Everybody okay with NBK? All right, discontinuities. Are there any discontinuities? No. Now, a little side note on discontinuities. Remember that to kind of check that, like even if it has any, if you start the far left part of the graph that you can get, all the way down there at negative infinity, which you can't really do. Draw the whole thing, which you can't really get to infinity. But if you never have to pick up your pencil, continuous. It could be a line segment and still be continuous. It doesn't mean that the domain has to be all real numbers. Does that make sense to you? Like if I just went from, if I had something that looked like this, which don't draw this because I'm going to erase it, but if I just had that and that was all that existed of my function, because from here to here, it's continuous. Does that make sense to you? Just keep in mind that it doesn't have to be they'd have to have an arrow on the end, basically. All right, so there are none. Is this even, odd, or neither? Odd. And what's our algebraic test for even or odd? Good. F of negative x, so in this case it would be negative x, right? And so that equals negative f of x. Okay. So one thing that we got lots of points taken off of on stuff is that you might have known it was even or odd, but you didn't actually make this statement. The reason you know it's odd at this point algebraically, I mean, I know we're looking at it too, but algebraically is that f of negative x equals negative f of x. So if you don't make the statement that it actually equals that, then you don't have all your stuff there. Now, we can look at this, just use this one visually, but it is odd. Okay? Everybody okay with all that? Any questions? All right, so we're going to do one more of these together. And it's actually on the second piece of paper. So I want you to find the exponential. Now, these do not go in your ISNs yet at all. I do not want, that's why there's no pages on there eventually. But we're not going to finish writing on them today. And if you glue them in before you're done, it makes it really hard to write on. So you can keep them in your binder and they can be not folded at all. If you want to fold it because you'd rather stick in your ISN and not actually glue it, that's fine too. But when you fold, if you do fold them today, which you don't even have to do that, but when you fold it like not in half, but where you could still see like the title. So you got part 1 and part 2. Does that make sense? But you don't have to fold it today either. All right, so let's look at exponential. So our exponential parent function, our variable of x, where is x going to be in this little equation? Like, where does x go? It's not, because it's not just f of x equals x, obviously. Like, how would you describe to me where it would be? It would be the exponent. We're on exponential. Well, it'd be in the exponent. That's why it's called an exponential, right? Now, some of these parent functions, you have to introduce a number in here. Like, there was no numbers in my, my linear parent function. Here, I have to have one. And I could have a lot of different things. I could have, 5 to the x or 7 to the x or 1,000,000 to the x, and they could all be considered the parent function. However, in this one in particular, this would be f of x equals what to the x power? What would be the base of my? Okay, so if I have 1, not 3. Okay. So 2, x. So whatever you can look at x, and if x equals 1, what does y equal? Well, that has to be your base. So this is 2 to the x power. I could have given you a different graph, and we could have used 3 to the x power and still have all the same sort of stuff going on here. Okay? All right, so whatever you're flipping through and doing, you need to do that later because we're on this right now. All right, so the domain of this, what would this domain be? Good, negative infinity to infinity. All of our x's are included here. What about our range? Is it all 0 to infinity? Because we can't have a negative. No matter what power you take 2 to, it's not going to make it negative. So I start 2, yeah. 0 to infinity. I never include my infinities. I almost look like crap. Do I include the 0? No, because I'm never actually going to make it there, right? Alrighty, so what are my x-intercepts? None. Part of your range, you're not going to have an x-intercept, so this is none. What's my y-intercept? 0, 1. So what if I changed my base? What if instead of 2 to the x power, I had 7 to the x power? Will my y-intercept change?
No, it would not.
If I had 10 to the x power?
No.
1,000,000 to the x power? No. Why doesn't it change? Tell me. Well, yes, 1 to any power is 1. But 0, 1, my x value is 0. So 2 to the 0 power is what? 1. What's 7 to the 0 power?
1.
What's 1,000,000 to the 0 power? 1. That's what you were trying to say. I know what you were trying to say, but it wasn't coming out right. So anything to the 0 power is 1. So no matter what the base is of my parent function, this right here is still the same. And this is going to be a very important point to us when we start to look at some of the other stuff going on. Okay? Mins here? No. Do I have any point of inflection? No. So this is none. None. You got it? Yes? Okay. Increasing, where does it increase? The whole thing. Good. So negative infinity to infinity. Now keep in mind, these intervals that you are writing are intervals of x. You are looking at what's happening to y, but they are intervals of x. So although I don't start increasing on the y value until I'm above 0, that has nothing to do with this. You are looking, as you go along the x, all the way from negative infinity to on the x-axis all the way to infinity, the function is increasing the entire time. Which means what's what's decreasing? None. All right, so our end behavior. As x approaches infinity, f of x approaches what? Infinity. So as x approaches infinity, f of x approaches infinity. And then as x approaches negative infinity, f of x approaches what? 0. We're never going to make it, but it approaches 0. So as x is going to negative infinity, y gets smaller and smaller and smaller. It's never actually going to make it to 0 and definitely never beyond. Okay, we good? Any discontinuities? Nope, it's none. Is it even, odd, or neither? Neither. Because again, if we find f of negative x, that's going to give me 2 to the negative x power. Does that give me negative 2 to the x? Okay, so it gives me either, you can look at it this way, 1 over 2 to the x power, or it is 1/2 to the x power, either way. Same thing, okay? Which, that is not f of x, and it's not negative f of x, and that's why it's neither. Algebraically, that's why it's neither. I think you can tell here there is no y-axis symmetry, and it's not, you can't rotate it 180 degrees, okay? We all good with that? Okay, so now I would kind of quickly glance at the functions that are on both sides of both of those pieces of paper. Which one is something you've never seen before? Signum. Okay, so I do not want you doing anything with signum yet. We are going to talk about it, why we care, what we do with it, whatever. So this one should be left completely blank. On the rest of them, with pencil, because nobody's perfect, you should be able to fill in as much as you can. All right, and here's why. Because today I'm giving you this and just kind of giving you a, here's, we're going to get started real quick. You have a test on this day, and then we're going to start talking about parent functions on this day. Because the great majority of this right now is review, I don't want to spend all the time talking to you about what you do with a quadratic. I mean, because give me a break. We should know that, right? I'd rather spend that time with the other stuff that you might struggle with a little bit. You're struggling with all of this, I don't know what to tell you. Grab your ISN from last year, because I'm pretty sure no matter who you had for Algebra 2, parent functions were a big deal, okay? So you should have most of this. If any of it is something that maybe you didn't do, I think you could probably figure things out. And that's why I want you to use pencils, see what you can do and see what you can get done. That way on Thursday, we're just going in there and kind of talking through it quickly. I'll spend a little time on some special points and then not just take forever to get through all these. Are we good? Because you don't have any, I'm not giving you any homework. Your homework today is to work on your test and test review, because that's due tomorrow, and then make sure you're ready for your test, and then get this done. So there's not really an assignment. Everybody good on all that? What I want you to do? All right, good deal. So let me stop this.